everyone. Notes 5.5 are on proving trig identities, and this is day 2. And we're going to go through and prove our identities, but also just write some little tips and pointers to help us out while we're doing our trig proofs. So for question number 1, I'm going to take the left side and I'm going to see what I can do with this right here. So first thing I'm going to do is I'm going to rewrite this in terms of cosine. And if you notice right here, we have two different expressions, but one's a fraction, one isn't. So right here, I'm just going to put a little star right here. And one of my suggestions to you is to find a common denominator, find a least common denominator. Okay, so if I were to look at this right here, I would make this over 1, and my least common denominator would be cosine to the power of 4x. So my first fraction that I see here, I don't have to multiply it by anything, but the second fraction, I have to multiply numerator and denominator by cos to the power of 4. So I end up getting right here that this is equal to 1 over cos to the power of 4x minus cos to the power of 4x over cos to the power of 4x. And then I can just put this together into a single fraction. So 1 minus cosine to the power of 4x all over cosine to the power of 4x. Remember, keep this left side right here in mind as you are going through your work that you're doing here. Now, another strategy or another little tip that's going to be helpful to you is when I take a look at this right here, I can see that I can't really do anything else within my fraction here. Like I can't simplify anything further. I can't put anything together. So another thing that I would try to do is factor as much as possible. Any factoring I can do will be good. So if you take a look at this numerator here, this is a difference of perfect squares. I have two terms. I have subtraction. I can square root 1, and I can square root x cosine x to the power of 4, cosine to the power of 4x. So because it's a difference of perfect squares, I can write this out as 1 minus cosine squared x and 1 plus cosine squared x. And that's all over cosine to the power of 4x. Now, when we get here, we should see that this right here is familiar to us because we can move the cosine squared over, so we get 1 minus cosine squared x, and that's what sine squared x is. So here I can replace 1 minus cosine squared x with sine squared x. So it's going to be sine squared x times 1 plus cosine squared x all over cosine to the power of 4x. And I'm now going to take a look at my right side of my equation right here. So this is really all I want to do with the left side. For my right side right here, I know that it is sine squared x plus sine squared x cosine squared x all over cosine to the power of 4x. And again, I want to work back and forth and see what I can find out that's in common. So right here, getting this common denominator of cosine to the power of 4x was a really good idea because I already have that on the right side. Now, again, I want to factor as much as possible. So if you take a look on this side right here, there is a sine squared x in common. So I can factor out that sine squared x. In my first term right here, I would end up getting a 1. And when I factored out of here, I would end up getting cosine squared x. And that's all over cosine to the power of 4x, which is exactly what we have been able to write our left-hand side as. So that means that our left side equals our right side. And so we have proven our identity right here. Another option I have is I could have just distributed the sine squared through and then just left the right side as is. It's up to you, whatever you prefer, as long as you understand what it is that you're doing. All right, in number 2, with my left side, I'm going to rewrite tangent of x as sine x over cosine x, and I'm going to rewrite cotangent of x as cosine x over sine x. And again, our strategy of getting a common denominator is going to be helpful here, right? So There's nothing more I can do to simplify this. There's nothing more I can do to simplify this. So I'm going to find an LCD, and my LCD is going to be cosine x sine x. So I'm going to multiply this by cosine x and multiply this by cosine x, because whatever I do in the denominator, I do in the numerator. Now I've got that common denominator that I want on the right-hand side. On the left-hand side, I'm going to multiply by sine x to get this common denominator here. So I end up getting right here in the numerator, I'd end up getting sine squared x, because sine times sine is sine squared, plus cosine times cosine is cosine squared x. And that's going to be all over sine x cosine x. Now I'm going to try to see if I can factor, or if I have any similar, any identities that I can use. And I do know that this right here is this identity right here. So I can replace 1 with sine squared x plus cosine squared x. So here I can just say that this is equal to, keep the denominator the same, and I can just put a 1 on top. And this right here, I can't really take this any further, so I'm going to leave this as is for right now. And now I'm going to play around with the right-hand side. So the right side says 2 cosecant of 2x, and cosecant means it's the reciprocal of sine. Now, a common mistake that people will make here is they will want to write 1 over 2 sine 2x, but this is wrong, because this is 2 times, right here, this is the 2 that I have right here. This is 2 times 1 over sine 2x, or in other words, it's just 2 over sine 2x. So this 2 stays on top, stays in the numerator, because the only thing that needs to be reciprocated is just this piece right here. Okay, so now I know right here that I have a double angle, and sine of 2x is equal to 2 sine x cosine x. So I can use my double angle right here. So here, instead of sine 2x, I can replace this with 2 sine x cosine x. But then I can say that this 2 and this 2 would cancel, right? They divide out, so I get 1 over sine x cos x. So I have shown that the left side equals the right side. So we have shown our proof. We've proven that the two sides are equal to each other. Okay? All right, in our last example here, we've got our left side and our right side. Let's start with our left side because we've got tan and cotan, and I just want to rewrite this using sine and cosine. And right here, I have 2 different fractions. So again, I'm going to try to get a common denominator. And my least common denominator this time is cosine squared x times sine squared x, which is pretty promising because that's the exact same denominator that we have in on the right-hand side. So this fraction on the left side is missing sine squared x. So I'll multiply numerator and denominator by sine squared x. This side over here is missing cosine squared x. So I'm going to multiply numerator and denominator by cosine squared x. And so this whole thing right here turns into sine to the power of 4x minus cosine to the power of 4x all over cosine squared x sine squared x. So I got sine to the power of 4x by multiplying sine squared times sine squared. I got cosine to the power of 4x by multiplying cosine squared by cosine squared. All right, cool. Now, there's not really a whole lot more that I can do with this. And if I go back and I look at all my identities that I have here, there's nothing about anything to the power of 4. So this isn't going to be helpful to me yet to use my identities. So what are some other things that we have done in the past? We said find an LCD, which we've done, but factoring is going to be really helpful as well. So right here, I'm going to factor. How do I know I can factor? Because when I look at this right here, I see a difference of perfect squares. I see two terms, I see subtraction, and I see expressions that are perfect squares. So I'm going to factor my numerator right here. So I end up getting, I know that it's, first I'm going to have brackets here. And I want sine squared x and sine squared x because that gives me sine to the power of 4. And then I want cosine squared x and cosine squared x because that would give me cosine to the power of 4. And one's a plus and one is a minus. And then I'm just going to copy down this numerator of cosine squared x, sine squared x. Okay? And now I can look back and see this identity right here, sine squared x plus cosine squared x, is the same thing as 1. So I can replace this entire expression with the number 1. It's super nice because it literally is just going to make everything inside of there disappear. Because when I multiply anything by 1, it keeps the number exactly the same. And this is going to be all over cosine squared x, sine squared x. So then right here, I end up getting, I don't really need to put the 1 there. So I end up getting sine squared x minus cosine squared x all over cosine squared x, sine squared x. Again, keep in mind that we are trying to show right-hand side equals left-hand side. So every time I'm going through this, I want to work back and forth between the two. However, the right side is literally this. This is the right-hand side. So therefore, the left side equals the right side. I've proven my identity, so my proof is completed. And we are all done with this trig proof and this video. Let me know if you have any questions. See you later. Bye.